Hello, statistical scholars, and welcome to another fun statistical video on how to do some hypothesis tests. So this is the chapter 10 content, one hypothesis test for one proportion. So let's get into it. And I'm also doing this on the calculator rather than Minitab for funsies. So, a claim is made that the proportion of children who play sports is less than 50%. A sample of Milton High School students are polled, and 580 of the 1,933 subjects say that they play a sport. Does this sample provide support for the claim? So we need to first state our null and alternative hypothesis, because if you remember, if your hypotheses are incorrect, the rest of this test will go very badly. So we need to make sure that we, let's make this purple for fun, have these correct. So the first thing you need to note is that your null hypothesis is always a statement about equality, and it's always a statement about the true proportion p. It's a claim of what it is, not the sample, not p hat. So I'm talking about all children, who play sports, not just high schoolers. Although that's really what my sample can support, really, is it's based on high schoolers. That's a little different. So we really claim that, yes, it is true that this is 50%. And the alternative option is the one we're going to look to either prove or deny, and that's that I really think it's less than 50%. That's what the claim is. They think it's smaller. Okay. So now the rest of these questions, the test statistic and the p-value, those are going to be answered by doing the actual hypothesis test. So I'm going to leave those off for now and actually perform the test on the calculator so that I can get these values. Boy, that didn't want to change. Okay, whatever. So we go into the stat menu and we're going to arrow over to tests where we found confidence intervals earlier. And if you notice on here, there's this option called one proportion z-test. That's exactly what we want. Let's arrow down there and hit enter. Now I got to give it some information. So notice there's this p naught. That's the value I'm hypothesizing against, which I think is 50%. And then it asks me for my number of successes, which is 580 out of the total of 1,933. And then my alternative. So do I think that I'm propping against or greater than that p naught? I think it's actually smaller. So that's the one. Dang it. Sorry. Oh, yeah. I hope it saved my settings. Okay. I gotta remember to use these arrows. Sorry, sometimes it gets mad when I use the keyboard, sometimes it doesn't. So I want actually this value here. So the one that's dark is the one it's selecting, and there are three possible alternatives. Either I think it's different, as in not equal to, I think it's smaller, I think it's greater. We think smaller, so that's the one we would choose. And then you have two options down here, calculate and draw. So if you want to see a picture of the calculation with the test statistic and the p-value on it, you would choose draw. I'm just going to choose calculate this time. I'm going to go through and do this one a second time and draw it so you can see what it looks like. So there it gives us our test statistic, our z, which it finds to be negative 17.58, sorry, 5818. There, that's probably enough. Okay, so the reason I giggle and chuckle at this is because that is such a small z. I mean, really, that's tiny, tiny, tiny. That tells me that I'm over 17 standard deviations away from the mean, which means that, yes, it makes a ton of sense that the p-value is so tiny that it's incalculable. It's pretty much zero, because, your likelihood of being smaller than negative 17 is almost nothing. Because remember, after 3 standard deviations away from the mean, there's only 0.3 of a percent left. There's nothing after 17 of them. Okay. Last but not leastly, we need to make our decision. Woo! Remember, p hat, that's the sample, not the p-value. P-value is right there. Sorry, I meant to say that earlier. Okay, so now we need to make our decision. And so we look at this and we say, hey, we compare our p-value, we compare our alpha. Notice the p-value is smaller, which means that my sample was not very likely. How unlikely? That unlikely. It's so unlikely in the event that H naught was true. So it really does support the claim that, hey, H naught appears to be not true. So we are going to decide to reject the null hypothesis. And so now we need to write a good conclusion that goes along with that. So I would say the evidence suggests that the proportion of students whom play sports is less than 50%. And let's just let right at the well, RP is really small. So I mean I could say at this point at the 5% level of significance, because usually we have to have some kind of support of why. Well, not usually. We always have to have some sort of support on why we made that decision. So but since my p-value is so like, yeah, it's super zero, I'm going to include that. Instead, p-value of 0. I'm having a really hard time typing today for some reason. So if you look at this, the evidence suggests, okay, I got to tell you what I've decided, that the proportion of students who, so that's what I've decided. I've decided to support this. It also needs to be in the context of the problem. So I'm talking about the students who play sports. And then the third thing you need is some reason why you made that decision. So I'm saying, oh, look at my p-value. Well, it's just lambastedly, like, really, really tiny. So there's just no way. Okay, so real quickly, I'm going to go back into, not the second key, stat, and then down to the one proportion z-test again. And what I'm going to do now is I'm going to select draw instead of calculate so you can see what it does. I mean, this is not going to be a great example of that because my p-value is so tiny. There's nothing on here. Normally what happens is your z will show up on here and it'll shade the area that it wants, or that it gets for the test. So that's lovely. Woohoo! Oh my gosh, I'm so yawny today. Okay, so let's move on to the travel agent. A survey of 1,045 people who took vacations last year found that 123 of them had gone on cruises. Based on this cruise results, the travel agent claims that less than 10% of all vacations are cruises. So I've got all this test stuff in here, and I really need to do those, don't get me wrong, but I really need some hypotheses. So my null in this case is going to be that I think it's actually equal to 10%, because it's always a statement about equality. And my alternative is that, hey, I think it's less than 10%. So that's what I'm going to be going with on my test statistic here. Alrighty, let's go ahead and perform that test. So we're going to arrow over to test. I want number 5, bonk. Now I got to give it some values. I want 10% this time. My number of successes is 123. My sample size is 1045. Oh, and I'm still dealing with a less than. Okay. Well, let's choose draw this time for fun. Oh. That seems bloody unlikely, doesn't it? Anyway, so for us, we would put in our test statistic, and that would be that z is 1.9076, which you should recognize that it's fairly big and positive, which is not a good sign for a less than sort of test. This would be better than for a more than. My p-value is very high. It's almost 97, well, it's a little over 97%. Woohoo! Okay, so based on our evidence, what we're seeing is, oh, my p-value is likely, which means this is support that my null hypothesis is actually true. So we would fail to reject in this case. Fail to reject. So as you look at this, you should be thinking to yourself, oh, I failed to reject, which means I'm not really saying that the null is true. I'm just saying that I have no evidence that it's not true. Remember, not true isn't the same as false in this case, which is super, super strange. And the other idea is that, you know, just because I prove somebody not guilty doesn't mean they're innocent of the crime. They might have actually done it. I just don't have the evidence to prove otherwise. So we're careful with this. The evidence suggests that, you know, about 10% of all vacations could possibly be cruises. See, I'm very non-committal with this, possibly. At the 5% level of significance. So just to kind of round this up, there's three things I look for in a conclusion. Failed to reject is not part of it. That's your decision, not your conclusion. Your conclusion is, hey, I told you what my evidence is going to point towards. I say it in the context of the problem, so I'm informing you on to what's actually happening, so I actually answer the question. And then I tell you what made me that decision, my pointer towards that evidence. That's it. Hope you enjoyed. I really like the pictures. Helps me tell, like, oh gosh, there's a lot. Or, oh no, there's very little. So, to each their own.